Today we will going to discuss about the delta modulation and adaptive delta modulation in a digital modulation concept. In case of the delta modulation is the one type of the pulse code modulation, and it is transmit all the bits which is used to code the sample. Hence the sampling rate and the transmission channel bandwidth are large in the PCM system. So to overcome this problem, the delta modulation is used. The delta modulation is the one type of the PCM, and which is transmit only the 1 bit per sample, and that percent the sample value is compared with the previous sample value, and it indicates whether the amplitude is the increase or decrease during the send. The input signal x of t, see here, the input signal x of t is approximated to the step signal by the delta modulator, and the step size is fixed. For this modulation concept, the step size is fixed. Hence the difference between the input signal x of t, the staircase approximated signal, is confined to the two levels, that is plus delta and minus delta. If the difference is the positive, then approximated signal is increased by 1 steps, that is the delta is the difference is the negative, then approximated signal is reduced by the delta. When the step is reduced, then 0 is transmitted, and once the step is increased, then 1 is transmitted. Thus for each sample only there is a one binary bit is transmitted at a time. The following figure shows that here is the amplitude, here is the binary bit sequence. There is a binary bit sequence is given. There is a 0 1 1 1 1 1 1 0 1 0 0 0 0 1 0 1 0. Then here is the amplitude is given, and once the bit 0 is transmitted, where step size is decreased. When 0 to 1, then 1 is transmitted, then your step size is increased. There is a x of t is the information bearing signal, and u of t is the output of the quantizer. Then the step size should be, and the delta is the step size, means this del is stands from the step size. Once the 1 is transmitted, then the step size is going to be increases, means from here to here there is a 1 2 3 4 5 6 times there is a 1 is transmitted, then 1 2 3 4 5 6 and 7, where 6 times there is a step size is going to be increases. Once the 0 is transmitted, then again your step size is decreased, then next is the 1 step size is increased, and from here the step size is decreases up to the here, means here the step size is going to be decreases, and this is the and this process is continuously happen. Then the principle of each delta modulation can be explained by the following set of the equations. The error between the sample value x of t is the information bearing signal, and x bar of t, there is a last sampled approximation of the staircase waveform. Then error signal is error signal at a present sample. It is the difference between the sample value of x of t to the last sample or previous sample approximation of the staircase. Means this equation represents that there is a error at the present sample. There is a E of n of ts, which is equal to x of n of ts minus x bar of n of ts. Then basically we can all u of n of ts at a present sample approximation of the staircase output. There u of n minus 1 ts, which is equal to x dash of n of ts, which is the last sample approximation of the staircase waveform. Then this equation, the quantity should be begins. There is a b of n of ts, which is equal to del sine e n of ts, and that is depending upon the sign of the error. Means e of n of t, the sign of the step size is decided by delta will be decided. Means b of n of ts, which is equal to plus if x of n of ts should be greater than the x bar of n of ts. Means the slope of the original information bearing signal should be greater than the step size. There is a last sample approximation, then its value is positive. If it is negative, then x of n of ts should be less than x bar of n of ts. Then from equation number 4, there is a equation number 4, and if b n of ts is the plus delta, then binary 1 is the transmitted, and b n of ts which is equal to minus delta, then binary 0 is the transmitted, and where ts is the sampling interval. Then dm transmitted, there is a delta modulation transmitter. In the following figure shows there is a there is a delta modulator transmitter, and here is the delta modulator receiver. Here is the delta modulator receiver. Here is the sampled input should be given, that will be given to the comparator, and in the comparator it will be able to compare. There is an error signal, there is a e k of ts which is equal to x k of ts minus x bar of k of ts. There is a difference. If this difference is the positive, then this output is a positive, means the plus delta should be given, which is given to the here. And there is a delay should be introduced from here. There is a u k of k minus 1 of ts. There is a sampling period. This delay should be introduced from here, and that will be given to the here. Here is the output comparator and input comparator should be given. Then from the figure, the accumulator and low pass filter are used. The accumulator generates the staircase approximated signal output, and it is delayed by the one sampling period ts. Then it is added to the input signal. If the input is a binary 1, then it adds the plus delta steps to previous output, which is a delayed. If the input of binary 0, then one steps delta is subtracted from the delayed signal. Then low pass filter has the cutoff frequency equal to the highest frequency in the xt, and this filters the smoothen the staircase signal to the reconstruction of the original information bearing signal x of t. Then after that, here the dm transmitter, basically from equation number 3 to 5, the summary in the transmitter, there is a u n of ts which is equal to u n of ts minus ts plus minus delta, and the previous sample approximation should be given. U of n minus 1 of ts is restored by the delaying one sample period ts. The sampled input signal x n of ts and the staircase approximated signal x dash of n of ts are subtracted to get the error signal. Then advantages and disadvantages of the delta modulation. Advantages of the delta modulation is that the first advantages, the delta modulation transmit only one bit of the one sample. Thus the signaling rate and transmission channel bandwidth is quite small for the delta modulation system. This in case of the delta modulation, it will be transmit only one bit for one sample, and the signaling rate of the transmission channel bandwidth is quite small for the delta modulation. The transmitter and receiver implementation is very much simple for delta modulation, and there is no analog to digital converter is involved in the delta modulation system. Hence the circuitry is very simple, easy to troubleshoot. But in the disadvantages of the delta modulation, there are the two disadvantages. The first is the slope overload, and second is the granular noise. See, with the x of t and u of t, this staircase output would not able to follow the information bearing signal from here to here, and there is a delta is the step size. Hence it would not able to follow the information bearing signal. Hence the error should be introduced, and this error is called as the slope overload distortion. And once the your DC signal and information bearing signal is in between the staircase, it is acting as a DC, but actually it is not in DC. At that time the error is introduced, which is called as the granular noise. Then slope overload distortion, which is called as the startup error. This distortion arises because of the large dynamic range of the input signal. With reference to the figure, the rate of the input signal x of t is so high that the staircase signal cannot approximate it, the step size delta, and become too small for the staircase signal u of t to follow the step agreement of the x of t. Hence, thus there is a large error between the staircase approximated signal and the original input signal x of t. This error is called as the slope overload distortion. So to reduce this error, the step size should be increased when slope of the signal is x of t is high. Means with the help of this figure, this is the information bearing signal, and from that information bearing signal there is a necessary to increase the step size just like this up to the here. Then next step is also increases up to the here. Third step is also increases up to the here. Means the staircase approximation it able to follow the information bearing signal, then and then only it is able to remove the slope overload distortion. But the step size of the delta modulator is remains fixed. The maximum or minimum slope occur along the straight line. Therefore, this modulator is called as linear delta modulation (LDM). Then the next, once your information bearing signal is in between the staircase, then it is acting as the DC signal, and due to that the error is generated, which is called as the granular noise. And this granular noise is called as the hunting noise. Then granular noise occurs when the step size is too large compared to the small variation in the input signal, and that is for very small variation in the input signal, the staircase signal is changed by the large amount of the step size. When your input signal is almost flat, the staircase signal u of t keeps the oscillating by plus minus delta around the signal, and the error between the input and approximated signal is called as the granular noise. And the solution of this problem to make the step size is keep as a small. The large step size is it required to accommodate the wide range of the input signal, and small steps are required to reduce the granular noise. The adaptive delta modulation is the modification to overcome these errors. Then in case of the delta modulation, there is two limitations or two disadvantages. There is a slope overload and the granular noise. Then we generate one new technology or new technique or modification in the delta modulation, which is called as the adaptive delta modulation. In case of the adaptive delta modulation, we able to increases the step size. Means whatever the slope overload and granular noise is generated in the delta modulation, that is overcome in adaptive delta modulation. Then operating principle. In the operating principle, to overcome the quantization error due to the slope overload and granular noise, the step size is made adaptive to variation of the input signal x of t. Then particularly in the step agreement of the x of t, the step size is increased. When input is varying slowly, the step size is reduced, and this method is called as adaptive delta modulation, which is called as the ADM. The adaptive delta modulation can take continuous change in the step size or a discrete change in the step size. Then transmitter and receiver is shown here. The transmitter and receiver will be shown, and this is the very important block to remove the limitations in the delta modulation. The logic for step size control is it will be control for the step size. Either the slope of the information bearing signal is very large, then step size is increases, and once it will be less, then step size will be decreases. Means your information bearing signal xn of t means the output is exactly follow the input. Then whatever the output, that output again at the receiver side, the logic step size control, and that logic step size control, this comparator output should be given to the quantizer and comparator, and the delay should be introduced and to recover the original information easily. Then for example, if 1 bit quantizer is high and the step size may be doubled for the next sample, then 1 bit quantizer output is a low, the step size may be reduced by the 1 step. Show the waveform adaptive delta modulator sequence of the bit should be transmitted. This is the binary data. This binary data should be varying from 1, 2, 3, 4, means there are continuous, there are the 4 ones. Hence your step size is going to be increases, u of t. Then z of t is the information bearing signal. Once the slope should be decreases, then exactly the same process, the receiver, the adaptive delta modulation, the first part generates the step size from each incoming bit. Exactly the same process is followed as that in the transmitter. And once the step size is going to be decreases, once the slope of the information bearing signal is going towards the 0, then the step size is going to be decreases, means there is a delay should be introduced, and with the help of the delay the step size is going to be decreases, means the previous input and present input decided the step size. If the previous input and present input, both inputs should be same, then it is keep as it is, and it is given to an accumulator to build up the staircase waveform, the low pass filter and the smoothness out the staircase waveform to reconstruct the smooth signal. Then advantages of the adaptive delta modulation. In case of the adaptive delta modulation has certain advantages over a delta modulation. First, the signal to noise ratio is better than the ordinary delta modulation, means the signal to noise ratio is better than the ordinary delta modulation because of the reduction in the slope overload distortion and granular noise. Because of the variable step size, the dynamic range of the ADM is wide. Then utilization of the bandwidth is better than the delta modulation. Then plus other advantages of the delta modulation are only 1 bit per sample is required, and simplicity of the implementation of the transmitter and receiver. So this video you have understand the delta modulation, the advantages of the delta modulation and disadvantages of the delta modulation, and these disadvantages, that is the slope overload and granular noise, that can be overcome in adaptive delta modulation. I hope that would you like to this video, please comment on this video, please subscribe my channel, and don't miss, please click on the bell icon. Thank you.